Hello again, everybody. These are our solutions to Quiz 5. It's from Spring 2023, Math 302 at Cal State Fullerton. And our first problem is coming down to Bézout's lemma. So let's read the question and we'll see how Bézout's lemma is involved. So we have three integers, a, b, and d. They're positive integers. Such that there exist s and t in the integers satisfying as plus bt equals d. So this should remind you of Bézout's lemma, which told you that you could always write the greatest common divisor of integers, say a and b, where they're not both zero, as a z-linear combination, right? You could write the GCD as a z-linear combination of the a and b, say. And this one, though, is kind of working backward. You're starting with this z-linear combination equaling something, and then we want to know what we can say about that something. So for example, what if the something is equal to 1, or what if the something is greater than 1? All right, so what is important here is to go back to the statement of Bézout's lemma, and in Bézout's lemma we would look, let's write this, Bézout's lemma, we would look at this set, AZ plus BZ positive. Okay, so these are all positive numbers of the form a times an integer plus b times an integer. And we knew two very important things. Number one, that if I took the minimum of this set, that it was equal to the GCD. Okay, so that was our first big important result. And the second was that if I had anything in this set, so if say U, or we can use even S and T, if S and T are in Z, right? So that'll give us something in AZ plus BZ, such that AS plus BT is positive, then the GCD of A and B has to divide this number AS plus BT. Okay, so Bézout's lemma gave us a couple of very important things. And we're going to use both of those in this problem. So first, if d is equal to 1, so that means I have found a combination, AS and BT, whose sum is equal to 1. Well, that means I have something in this set, AZ plus BZ positive, equal to 1. That means it is the absolute smallest thing I can possibly get. Right? So the smallest possible element of AZ plus BZ positive, right, for any AB, right? We don't have to know what A and B are. For any A and B is 1, right? You have to have things in here that are positive. Well, the smallest positive number is 1. So if 1 is in that set, right, if I can write 1 as equal to AS plus BT, then 1 must be the minimum. And we know that the minimum is equal to the GCD. Okay, so if 1 is in AZ plus BZ positive, then 1 is definitely equal to the min of AZ plus BZ positive, and that's equal to the GCD of AB by Bézout's lemma. And so what can we say about the GCD in this case? We can say that the GCD, right, so this is in part A, we can say that the GCD of AB is equal to 1. Okay, this is what most people who've seen Bézout's lemma will guess without thinking through the logic. And the problem is this: people will start saying, oh, I can write D as AS plus BT. Oh, then D is the GCD. And that's just simply false, right? There's a lot of things that we can write in the form AS plus BT, and only the smallest one, the minimum one, is going to be the GCD, at least if we look at the positives. All right? And that's where even if you get one or part A right by accident, you're probably not going to get part B right by accident, because here in part B, we're assuming D is greater than 1, and we want to know what we can say about the GCD. Well, maybe, let's say that D was, I don't know, how about 12? right? So what if D equals 12? All we know from Bézout's lemma is that the GCD divides anything of the form AZ plus BZ positive. Well, D, 12, is of the form AS plus BT, right? That's in the right form. So if this was true, right, all we would know is that the GCD of A and B divides 12. That's it. So it could be 2, it could be 3, it could be 1, it could be 6, it could be 4, right? It could be 12. Okay, but there's a lot of options. So all we can say in this case, right? All we can say, if D is greater than 1, then we know that the GCD of AB divides D. That's it, right? That's all we get. We don't get equality anymore.